Okay, so 7.3 is all about how we can use polynomials to look at problems like rolling a dice and other types of repeated experiment type things. And so question number 5 from your worksheet said, what is the probability of getting a sum of 12 in 4 spins as described in number 3? So the spinner on it had the numbers 2, 4, 6, 6, and 16. The book did a nice job of explaining in the Habits of Mind how the numbers that you can get on each spin, how they relate to the exponents. So since you can get a 2 with the first spin, that's why this is x squared, a 4, that's why this is x to the 4th, x to the 6th. There's actually 2 ways to get the number 6, so we made this a coefficient of 2 with the exponent of 6. And then here we have x to the 16th because you can get 16. The power overall is the 4th because you have 4 spins that you're doing. And again, the basis of this method is the idea that when you're multiplying things, you end up adding the exponents. So that's why it's works, and the book explains that very well in the Habits of Mind. Okay, so now we have this problem of trying to expand this expression. What we can do is either use a CAS system, which is a TI-89, it stands for Computer Algebraic System. If you don't have a CAS system, you can also use GeoGebra. So if you have the GeoGebra 4, it can do a lot of these algebraic things for you. In the bottom right corner it says it has input. So if we go and click on that, it should open up all your commands on GeoGebra. This is an algebraic thing we're trying to do. We're trying to expand the expression. So I'm going to select the expand feature, and then if I click on the paste, it pastes it in to the input bar. So I'm just going to type in what we're trying to expand. It was x squared plus x to the 4th plus 2x to the 6th plus x to the 16th, and we're taking that all to the 4th power. And so now if I press enter, it has expanded that expression for me. So now all I need to do is go through and interpret this. This is 1x to the 64th. So they're saying there's one way to get a sum of 64 in the 4 spins. You'd have to get 16 each time. There are 8 ways to get a sum of 54, 4 ways to get a sum of 52 in your 4 spins, and so on. So all we're going to do is look for, specifically for a sum of 12. So here's our sum of 12. There's 14 ways to do that. So our probability would be 14, which is our coefficient of the x to the 12th, over 625. Okay, the 625 comes from the fact that there's 5 possible numbers you could get on each spin, a 2, a 4, a 6, another 6, or 16, and you're spinning that 4 times. So that's just counting the total number of ways to do that. Okay, so you can also use these polynomials for dealing with guessing on test type questions. Okay, so if a multiple choice test has 10 questions and each question has 4 choices on it, what is the probability that you get at least 70% if you're strictly guessing? So there's 1 correct option and 3 wrong options. So I just use C for correct and W for wrong. We're looking at 10 questions, so we did to the 10th power. If you have a TI-89 CAS system, you could, and most of those you could enter this in as it's written. If you're using GeoGebra, GeoGebra will only recognize X and Y. So I converted it over to X to stand for correct and Y to stand for wrong, basically. So we want to expand X plus 3Y to the 10th. So again, I could go to GeoGebra. I'm looking to expand, so I could expand, and it's X plus 3Y to the 10th because there's 10 questions. And I've expanded. So now this tells me that there's one way to get all 10 correct. There's 30 ways you could get 9 correct and 1 wrong. 405 ways you could get 8 correct and 2 wrong. And 3,240 ways you could get 7 correct and 3 wrong. And if we scroll, you can see the rest of them. You can also make this window bigger and smaller so you can see more or less of the problem. Right? So we basically have to find a probability. So their probability, we had one way to get them all correct, and then 30, and then it was 405, and then looking back, there were 3,240 ways to get 7 correct and 3 wrong. So 3,240. Okay, so that's the ways we could get at least 7 correct. And then since there's 4 choices per question, and there's 10 questions, there's 4 to the 10th total ways that this could happen. Okay. And if we found the decimal equivalent to that, that is about 35 10,000ths. So less than a 0.5% chance that you would get a C minus or higher on just 10 questions where there's 4 options each. And we could apply similar logic if we had more or less questions and more or less choices, just adjusting the number correct options, the number of incorrect options, and this exponent.